So today we're going to start on homework 4. So this says that solve the modular equation that x is congruent to 9 to the 430th power mod 35. So what we need to apply is Euler's rule here. So we know that 535 equals 24. So from that I can say that 9 to the 24th power is congruent to 1 mod 35. So then I can raise each side to the 17th power. So that gives me 4 to the 24 times 17 is still congruent to 1 mod 35. And then I multiply each side by 9 to the 22nd power. So that will give me 9 to the 430 is congruent 2 to 9 to the 22nd mod 35. Therefore, what this gives me is that x is congruent to 9 to the 22nd power mod 35. So now what do I do from here? Well, the trick is that 22 is close to 24. So what I can say is that 9 squared x is congruent to 9 to the 24th mod 35, which equals 1 mod 35. So now I have to solve the equation that 81x is congruent to mod 35. Well, what I can do from here is the following. I know that 81 mod 35, that's going to mean 11x is congruent to 1 mod 35. So I'm going to multiply each side by 3. That's going to give me dang, I'm hungry again. Oh gosh. Nah. Yeah. So with 11x, I get multiply each side. That's 33x is congruent to 3 mod 35. Mod that. So I get negative 2x is congruent to 3 mod 35. That's 2x is congruent to negative 3 mod 35. Then I have a simple equation that I can solve for 2x plus 3 equals 35n. Right, so setting n equal 1, I can set that 2x equals 32 and then x equals 16. But remember, it's a modular equation, so all my solutions are of the form that 16 mod 35. End proof. Number 2 asks the following. It says that show that 91 divides into the difference of n to the 12th minus a to the 12th, given that a and n are relatively prime to 91. So with the relatively prime part, that gives me a few hints. So what they're basically asking is the following. So they just want they want me to prove that n to the 12th minus a to the 12th, right, is congruent to 0 mod 91. So let's start off with a few definitions. So mod 91. Given this, that I know that I need to apply the Euler's phi function. So I can say that 591 equals 57 times phi of 13. So here I can kind of separate into two categories, 57, 513. This tells me that n to the 6th is congruent to 1 mod 7, n to the 7th, or sorry, a to the 6th is congruent to 1 mod 7 as well. And for phi of 13, that tells me that a to the 12th is congruent to 1 mod 13. And n to the 12th, I probably should switch the order, is congruent to 1 mod 13. So with the 7s, let's square each side. So n to the 12th, Roger, n to the 12th is 1 mod 7. So with a, we can say that it's a to the 12th is congruent to 1 mod 7. Now notice that we have the same exponents here, n to the 12th, n to the 12th, a to the 12th, and a to the 12th. So now with these mods, I can combine them as follows. So then I can say that n to the 12th is congruent to 1 mod 91. And then a to the 12th is congruent to 1 mod 91. And therefore the difference is going to be 0 mod 91. So number 3 asks that prove that n to the 5th over 5 plus n cubed over 3 plus 7n over 15 is always an integer. So with what this is saying, that I can also, it's basically saying that 3n to the 5th plus 5n cubed plus 7n prove that this expression is an integer. So well, what I did from here is that I multiplied this by 15. So what I need to show is that this mod 15 equals 0. So to be mod 15, that means it's also divisible by 3 and also divisible by 5. So let's see what happens when I take this expression and take mod 5 of it. Well, this thing goes away. So I have 3 to the n to the 5th plus 7n. Well, let's divide this n to the 5th part. That's 3n times n to the 4th plus 7n. So with n to the 4th, I can reduce that to 1 because of because of the Euler's phi function or totem function. So now this will get 3n plus 7n, which is 10n, which is divisible by 5. So that, well, when I take mod 5, that's always going to be 0. So it's going to be the same thing here. So then I have, with mod 3, this value goes away. So I have 5n cubed plus 7n. So again, I can separate this out to be n squared plus 7n. And again, with the mod 3, this will go away to 1. So then I have 5n plus 7n, which equals 12n, which when mod 3, that's 0. So I'm done, because then I just showed that 3 divides into this expression, 5 divides into the expression, therefore 15 divides into this expression, therefore this will be an integer.